Waves aren't limited to traveling through water. They're everywhere. Every sound you hear consists of sound waves. All the light we can see consists of electromagnetic waves. You are bombarded with waves all day and all night long. Since waves are traveling all around us all the time, they must at some point come into contact with each other. Do they smash into each other and stop? Do they pass through each other without interacting? Or do they do something else entirely? In this lesson, we're going to look at what happens when two waves run into each other. Specifically, we're going to focus on how this affects waves' maximum displacement, or amplitude. When two waves come into contact with each other, they don't collide. They pass right through each other without any change in their original speed or direction. However, they do interact as they pass through each other. Only waves of the same type can directly interact with each other. This means a sound wave can interact with another sound wave, or a light wave can interact with another light wave, but a sound wave cannot interact with a light wave. We call the interaction of waves with another wave interference. We describe how these waves interact through the principle of superposition, which states that two interfering waves cause a displacement in the medium they're traveling through, equal to the sum of the individual waves' displacements. To try and better understand the principle of superposition, let's look at an example of what we get when two waves interfere with each other. The resultant wave is the purple wave created by the red and green waves interfering with each other. By using the grid, you can see that the resultant displacement at any given point of the resultant wave is equal to the addition of the displacements of the other two waves at that same point on the x-axis. Essentially, the waves are overlapping to create a bigger or smaller wave, depending on how they interact. The maximum displacement of a wave is known as its amplitude. A periodic wave's amplitude is located at the highest point in its peaks and lowest point in its troughs. Here, we have a positive amplitude and a negative amplitude. In this case, the negative sign is there to show the direction of displacement. One of the amplitudes is in the opposite direction from the other, but the magnitude of displacement is the same. Since a wave's amplitude is just the maximum displacement of a wave, we can use the principle of superposition to find the amplitude for a resultant wave. The resultant amplitude of the wave we get through the combination of the two interfering waves is equal to the addition of the displacements of those two waves at the same location as the resultant wave's amplitude. A sub r equals d sub 1 plus d sub 2. When you have two superposed waves, there are two different types of interference that can occur. The first of these is called constructive interference. We get this type of interference when the two waves' displacements are in the same direction. With constructive interference, the resultant amplitude will be greater in magnitude than the magnitude of the displacement of the larger of the two interfering waves. The second case happens when the two waves' displacements are in opposite directions. We call this destructive interference. The resultant amplitude will be smaller in magnitude than the magnitude of the displacement of the larger of the two interfering waves. When we only look at the magnitude of a displacement or amplitude, it means we're not concerned with direction. In this case, that means the negative sign is ignored. When two waves of the same type pass through each other, they interact by creating wave interference. We describe this interaction with the principle of superposition, which states that two interfering waves create a displacement in the material they're traveling through, equal to the sum of their individual displacements. Since wave interference affects wave displacement, it makes sense that it affects amplitude as well. Amplitude is the maximum displacement of the wave. The resultant amplitude of two interfering waves is equal to the sum of those two waves' displacements at the same location as the resultant wave's amplitude. A sub r equals d sub 1 plus d sub 2. There are two main types of interference, called constructive and destructive interference. Constructive interference occurs when the two waves' displacements are in the same direction. The resultant amplitude is greater in magnitude than the magnitude of the displacement of the largest interfering wave. Destructive interference occurs when two interfering waves have displacements in opposite directions. This time, the resultant amplitude is less in magnitude than the magnitude of the displacement of the largest interfering wave.